All right, we're going to look at sequences. A sequence can be thought of as a list of numbers written in a definite order. So here you can see an example of a sequence. A1 here, that would be the first term. A2, that would be our second term, and so on. And we would keep going with this infinite sequence. So we could write each term then as eighth event. So out here somewhere would be some other number in that sequence. The term after that one would be the term ace of n plus 1 plus 2 and so on. So every sequence we can list out in that notation. Some sequences can be defined by giving a formula for that nth term. In the following examples, we will look at kind of how you can do that for each one. So this first sequence here, you can see that we have this as the nth term, starting at 1 and going to infinity. So that the ace A of nth term then would be that same thing that we see written here. So for example, if we were to do this, the first number we'd want to plug in is 1. So if we plugged in 1 here for n, this would equal 1 on top. On the bottom, we'd have 1 plus 1 is 2. So the first term in that sequence then would be 1/2. If we go on to the next one, now we go up a number from that. So now we're plugging in 2. If we plugged in 2, we'd have 2 plus 1 on the bottom is 3. Next term would be 2/3. We could continue that. Next one would be 3/4, 4/5, and you can kind of see the pattern happening there. Both the top number and bottom number are increasing by 1. So the next term here would be 5/6. The next one would be 6/7, and so on. And so if we are coming up with an equation for that one, on the top we'd have n, and then the bottom number is always 1 more than the bottom. That's why you see n plus 1 written on the bottom. Let's try another one here. So if you look at this next series here, or sequence here, we got -2/3 as the first number, 3/9 as the next number, -4/27, 5/81. So you can see a couple of patterns here. One of the patterns being that this one here alternates between positive and negative. So that's one thing going on. You can see on the top, this increases by 1. On the bottom, it's a little harder to see the pattern, but it looks like it's timesing by 3 each time. If we go from here to here, that's times 3. If we go from here to here, that's times 3. Here to here, that's times 3. That means they're all multiples of 3 there. So the pattern here, whenever you are alternating between positive and negative, you'll see that when we try to come up with the nth term, we can do that by putting -1 in a parentheses to some power of n. And the reason that this works is if you put a positive or a odd number in here, it'll make it negative. So like when we put 1 in for the first term, that'll -1 to the first power is negative, and we got a negative first term there. If you put a even number, like for the next one, -1 squared, well, -1 times -1 is +1. That's going to make this come out to be positive. So that's how you can alternate in between positive and negative if your sequence does that. One other thing you'll see, if the first term is positive instead of negative, then you can just write this as n to like the either +1 or -1, and that'll make the first term come out to be or first power come out even to make that first one positive. All right, increasing by 1. That's kind of like on our last one here. We had that n plus 1. So we could do n plus 1 here to get that first top number to be 2 when we put 1 in. And then because we have multiples of 3 on bottom, it could be written as 3 to some power. So if you put like 1 in on the first one, that'll make it 3. For the next one, if you put 2 in, that would make it 9. On the next one, if you put 3 as the power, that's 27, and so on. So that's the nth term written here. You can see some other ones here. Some things to notice on some of these other ones. Your first term doesn't always have to start with 1. Like here, they're starting the sequence at n equals 3. So if you put 3 in for the first one, 3 minus 3 is 0. Square root of 0 is 0. That's why you see the first one written here as 0. If you put 4 in, 4 minus 3 is 1. Square root of 1 is 1. And then you continue that pattern there. So there's another example. You can have trig in on the next one. You notice this one starts at 0. Again, don't have to start at 1 when you're doing a sequence. And here, this would be looking like you'd be doing some of those main unit circle ones now if you got n pi over 6 here. So if you put 0 in, cosine of 0 is 1. If you put 1 in there, it'd end up being cosine of pi over 6, which is square root 3 over 2. If you put 2 in, that would be cosine of 2 pi over 6, or that's just the same as pi over 3. That would end up being half, and so on. So you can do trig ones here as well. Let's see if we can come up with one. So here we got this sequence here. We want to try to find the pattern and then see if we can write that a sub nth term out there of what that would be. All right, so let's see what's our pattern going on here. Well, one thing we can see, it alternates between positive and negative. So one pattern thing here is we're alternating positive and negative. Okay, what else is going on? Looks like on the top here, we are, so in the numerator, we're increasing by 1 each time. And in the denominator, what's going on there? You got 5, 125, or sorry, 5, 25, 125. Those are all divisible by 5, and it does look like in the denominator we're multiplying by 5. So denominator, they're all going to be powers of 5. So when we're trying to come up with that nth one, those are all things to keep in mind here. So let's see if we can write out what that nth term is going to be. So our a sub nth term. Remember how we talked about before, if we want it to alternate between positive and negative, in our thing here, we're going to want a negative 1 now to some power. And if we want the first one to come out to be positive, we got to make sure that whatever we put in for that first one is going to work. So let's say we did it just as n. So if we put 1 in as our first one, that's not going to make it positive. Negative 1 to the first power is going to be negative. So we want to add either a plus 1, or I think minus 1 would also work, because if we put 1 in now, 1 minus 1 is 0. Negative 1 to the 0 power is positive 1, so that would work for this one. All right, now let's see if we can get those numbers that come out. So we want it to increase by 1. If we put 1 in, or n in, if we put 1 in right now, that's just going to be 1. But our first term here, you can see, is 3. So I think what we want to do here is add a 2 on that to make that first one 3. And then if we keep increasing the number, we'd increase by 1 each time. All right, on the bottom, remember we said these are all powers of 5. So we want to write a 5 down here. We want the first one to be 5. So I think if we put that to the power of n, it's going to work out just fine. So if we put 1 in right now, it'd be 5. If we put 2 in for the next term, 5 squared is 25. If we put a 3 in, 5 to the third power is 125. Looks like that's going to work. So that would be the a sub nth term right there. That would give you any term in this sequence starting with n equals 1 going to infinity. So if we wanted here, we could be more specific, n equals 1 to infinity. All right, one other term that's very popular is this one. Find the pattern for this sequence. So 1, 1, 2, 3, 5, 8, 13, 21. Not quite as easy to recognize this one. We're not necessarily adding the same thing each time, especially with the 2 ones to start out with. I don't think there's anything we could multiply either to continue this sequence. This one's a special one, and the pattern here is what's called uh, um, a recursive one, because to get from one number to the next, you can't actually just use one number, you have to use 2. So for example, here, if we add these first 2 numbers up, 1 plus 1, we get 2. If you add the next two, the 2 numbers together now, so I'm talking now 1 and 2, you get the next term 3. If you add now these 2 terms, 2 and 3, you get 5, and that continues on as far as you go. So the pattern here is you take the first, or any 2 consecutive ones and add them together. And there's a special name for this one called the Fibonacci sequence. So it's a recursive sequence, meaning the next term depends on more than just the preceding term. You got to use the previous 2. So if we wanted to write this one out, well, I mean, if we keep going here, just an example, if we wanted to find the next term here, what would the next one be? The 1321. So our next one here, if we added these 2 up, we would get 34 would be the next one in that sequence, and so on. So you're always adding the next 2. So let's see if we can come up with the ace of nth term for this one. So what would ace of n be here? Well, it would be the 2 previous ones added together. Well, the term before ace of n would be ace of n minus 1, because if we go back a term, that would be the term just before it. But we don't just take that term, we need the one before that one added to it. So the one before that one would be ace of n minus 2. So that's what a recursive formula looks like. It means you are going to, your next term depends on ones that precede it. So when you're writing out a recursive formula, don't be surprised to see that you have multiple terms in here that are in that sequence.